Back in February of 2021, a brutal cold snap completely paralyzed the central United States, and it created a crisis of really historic proportions. So, how did that happen? And maybe more importantly, why didn't our best forecasting tools see it coming? Today, we're going to crack open the case file on this climate mystery. The impact was just staggering. I mean, this wasn't just another cold spell. It ended up being the single most expensive winter storm in American history, an event that was exceptional for its persistence, its intensity, and just its massive geographic size. And the human cost? It was huge. Across Texas alone, the power grid failed, and that left close to 10 million people without electricity and clean water. For some, it was for weeks on end, all during these dangerously, dangerously cold temperatures. So this brings us to the central question of our whole investigation. Was this just a total freak event, a complete surprise out of nowhere? Or were there clues hidden in the climate system that we just missed? Let's find out. Okay, so our investigation begins with a really critical failure, the forecasts. Because weeks before the disaster, the predictions looked, well, they looked completely normal. That's right. 3 to 4 weeks before this whole thing went down, the major operational models, the workhorses of weather prediction, they were all calling for an average or even an above-average February. No alarm bells were going off anywhere. And wow, this slide right here shows you the problem perfectly. You don't need to be a meteorologist, just focus on the colors. On the left, that's the prediction from the standard, trusted forecast model. See all that orange and yellow? That means warmer than average temps, business as usual. But now look at the right. That's a forecast from an experimental model for the exact same time period, and it is a sea of deep, cold blue, signaling a historic freeze. I mean, two models, two totally opposite futures. So yeah, this one experimental model saw something that all the others missed. It confidently predicted a really high risk of this cold air outbreak a full 3 to 4 weeks ahead of time. That's up to 2 weeks before the standard models even caught on. So who is our star detective in this story? Well, it's a new kind of forecasting tool. It's called the linear inverse model, or LIM for short. And you can think of it like a weather predicting AI that doesn't just tell you if it's going to rain, but it can work backward and tell you exactly why it's going to rain. It doesn't just see the future. It actually understands the cause. Okay, so let's use our new detective to unmask the culprits behind this thing. It turns out this wasn't the work of a single villain, but more like a conspiracy of 4 different climate phenomena, all acting together. By using the LIM to sort of filter all the climate data, researchers could actually isolate the individual fingerprints of these 4 accomplices. And it turns out each one played a really specific role in creating this perfect storm. Our first culprit is a name you've probably heard before, La Niña. This big pattern of cooler than average ocean temperatures out in the Pacific, that was the background condition for the entire winter. So think of La Niña as setting the stage. It didn't pull the trigger itself, but its presence was changing atmospheric patterns all over the globe, basically making it easier for cold Arctic air to plunge south into North America. It kind of loaded the dice for a cold winter. Culprit number 2 is a much more dramatic character, a sudden stratospheric warming, or SSW. This is a huge disruption that happens way, way up in the atmosphere, about 10 to 30 miles above our heads. So, in early January 2021, there was this powerful SSW event, and it just hammered the polar vortex. That's the band of winds that usually keeps cold air locked up over the Arctic. But here's the crucial part. The full effect wasn't felt right away. It actually took weeks for that impact to trickle all the way down through the atmosphere to the surface where we live. And the final 2 accomplices, well, they were the knockout punch. First, you had something called the Madden-Julian Oscillation, which is kind of like a wave of stormy weather that travels around the tropics. It gave the system another nudge. And then finally, you just had plain old random weather, the chaotic, unpredictable nature of the atmosphere itself, which delivered that final intense surge that turned a major cold spell into an historic one. So, we have our 4 culprits, but just identifying them, that's only half the battle. The real mystery is how they teamed up to produce something so extreme. Right, this is the critical question. La Niña was around in December and January, but there was no deep freeze. So what changed in February? What was the secret ingredient that made everything go so wrong? And the answer is just fascinating. These factors didn't just add up. No, they multiplied. The conditions that were already there and the new triggers that came along, they amplified each other, creating a risk that was way greater than the sum of its parts. Now, this chart right here, this is the aha moment. Take a look at the first bar. With just La Nina, the risk of a deep freeze was already 2 to 3 times higher than normal. Okay, that's significant. But now look at the second bar. This is what happens when you add in the delayed effects of that sudden stratospheric warming. Boom. The risk just jumps dramatically, becoming 3 to 5 times more likely. That is the multiplication effect right there in action. This perfect alignment is what creates what scientists call a forecast of opportunity. The LIM model was so successful because it was able to see these two big predictable signals, the long-term La Nina and the lingering effects of the SSW. And it recognized that when they lined up, it spelled big trouble weeks down the road. So, with the case of the 2021 freeze largely solved, we can now start to look to the future. I mean, how often can we expect something like this to happen again? By running a massive 3,000-year climate simulation, the LIM model came up with a pretty stunning estimate. An event of this specific severity has an average return time of about 26 years. So that means it's a rare event, definitely in the top 1% of severity, but it is far from unprecedented. In fact, the last U.S. cold snap that was even in the same ballpark happened 32 years earlier, back in 1989. So, here's the bottom line. The 2021 Texas freeze wasn't a random bolt from the blue. It was the result of a predictable conspiracy between these huge climate patterns, and it was amplified by just unpredictable weather. And what it shows us is that new tools, like machine learning, are giving us the power to see these kinds of threats coming earlier than ever before. The science has given us the playbook. We can identify the culprits. We can see the clues when they start to line up. So the final question then, it really isn't for scientists anymore. It's for all of us. Knowing what we know now, will we be prepared for the next perfect storm?